Good afternoon. My name is Min-Hsiung. The title of my presentation is Novel Automatic Control Scheme for Efficiently Developing Cloud Manufacturing Services. All come from Intelligent Manufacturing Research Center, National Cheng University, Taiwan. First, I will introduce the background and objective. Cloud manufacturing has become a hot research topic for smart manufacturing. Cloud manufacturing's main concept is to encapsulate and virtualize distributed manufacturing resources into cloud service that can be used on demand over networks to support the manufacturing activity. Here show a cloud manufacturing example. We developed a smart manufacturing platform, AMCOT. In this figure, we apply the AMCOT to a semiconductor bumping process. On the cloud side, we developed various intelligent cloud manufacturing services, including AVM, automatic virtual metrology services, IPM, intelligent predictive maintenance service, and IYM, intelligent year management service for supporting manufacturing activity. MCOT has been successfully applied to several manufacturing industries, including semiconductor industry, wheel machining industry, aerospace industry, and stretch blow molding machine industry. MCOT needs to provide different cloud manufacturing services for different industries. For example, in addition to the AVM, IPM, IOIM services, we need to also provide the tool-aware prognostic service for wheel machining industry and provide the round-to-round control for stretch blow molding machine industry. Previously, we construct this cloud manufacturing service manually. However, manually transform local software into web service take a lot of programming effort, which is tedious and error-prone and time-consuming. So this motivates this research. So we want to develop an automatic way called MSACS for solve this issue. In the service computing field, there are many service composition methods which can optimally compose multiple atomic web services to create new value-added services, but they did not address how to automatically build this atomic service. This paper proposed a novel manufacturing service automatic control scheme called MSACS, aimed at facilitating easy and rapid construction of the cloud manufacturing service for industry. So then I show the workflow and architectural design of MSACS. This page illustrates the procedure of manually developing a cloud manufacturing service. The developer opened the IDE and developed a web service project, then build this web service project to generate a web service package, which is then deployed to the cloud to become a cloud manufacturing service. The tedious part in developing web service project is we need to manually manage the libraries, the package, and develop source code and set the UI or API. Here show example code of web API. If needed build a web API, the developer needs to repeat n time of such coding, which is tedious and time-consuming. So this page shows the automatic workflow of the MSACS. For comparison, I put the many workflow of the IDE at the top and show the automatic workflow of MSACS at the bottom. The main idea is we develop the key KI extractor, key information extractor, can automate it to extract the key information from the library and store this library into a library info file. And then develop GUI to show all the information of the library on the GUI. So then allow the user to choose the method they want to build as a web API. Let's select the information of the selected web API will store into the service interface info file. Then we use the web service project generator to automatically generate the source code of the web service project. Then you use the service constructor automatically to construct a web service package. Then use the service manager to deploy to the cloud to become cloud manufactured service. Then we put the key component to form architecture. So here the MSACS is a cloud-based system whose architecture consists of 3 parts. The first part is a manufacturing constructor for constructing service. The second part is a service manager for deploying service. The third part is a cloud web server for hosting service. So I use the GUIS to illustrate the MSACS the operation. First, the user use the GUIS to upload the library, then click the start parsing. So the KI Extractor will generate the library info file. After that, the system will show all the methods on the GUI. So the developer can choose the method they want to build as an API, then select it down. The system will automatically generate the service info file. Then click construct service button. The system will automatically first generate the web service project, then further create the web service package. Finally, click the deploy service, then type in the IP address of cloud web server. Then the cloud manufacturing service is constructed. Then the GUI will show all API of the cloud manufacturing service. So you can see this is an easy and efficient way to create a cloud manufacturing service. How we can achieve that? So due to time limit, I only mentioned 2 co-functional mechanisms, the KI Extractor and the WSP generator. In order to develop the algorithm of the KI Extractor, we need to do the analysis, to analyze the package. First, this is Java library structure showing the decompiler. You can see it contains 3 layers. The first layer contains the library name. The second layer contains the package name and the class name. The third layer contains all the methods information. We conduct a similar analysis on the C# library. It also contains 3 layers. So we assign the symbol to each layer's information. Using this design symbol, we are able to develop a generic algorithm of the KI Extractor. The first part can extract the library name. The second part can extract the package and the class name. The third part can extract all the methods information. Then I show the functional module of the web service project generator. First, we design WSC template with annotated keyword. Then we design a lookup table which contains annotated keyword and the corresponding code generation format. Then we develop the code generation algorithm, which can read through the service information file. For each API, he will refer to the WSP template and look up the lookup table to replace the keyword with the corresponding code generation format, which can generate the source code of the web service project. The following, I will show 3 industrial case studies and give a demo. In case study 1, we apply the AVM service created by MSACS to wheel machining automation of FATEC. The left figure shows a production line consisting 3 machine tools, OP1, OP2, and OP3. The right figure shows the predicted VM value of the central hole diameter for OP1. Testing results show the AVM service created by MSACS perform VM very well. The predicted value closely following the actual value. In case study 2, we apply the IVRM service created by MSACS to a semiconductor bumping process. Bumping process is complex. Many factors will affect the yield. The purpose of the IVRM service in this case is to find the root cause of the final defect 1. The figure below shows the IYM service created by MSACS successfully find the top 10 most suspicious process parameter causing final defect 1. So in case study 3, we conduct the performance evaluation of the MSACS. So the testing results show that MSACS is 30 times quicker than, on average, quicker than the professional programmer, 22 minutes versus less than 1 minute in creating a web API. Then I show a demo.
The API information selection is done, we construct the surface. Here you can see the surface was constructed successfully. Now we deploy the surface by specifying the IP address of target web server. Here it displays the information of web API, and this indicates that MSACS successfully construct the cloud manufacturing surface. We're going to test the AVM surface created by MSACS. You can see that OP1 machine starts the machining process. And after the machining process completes, the system will call the AVM surface created by MSACS. And AVM surface starts to compute the results. And here the GUIS shows the predicted value of center hole diameter. This validates the effectiveness of MSACS.
Okay, finally I make a conclusion and the future work. The MSACS can automatically construct a target cloud manufacturing service in a very easy and efficient manner after uploading the required library. MSACS can significantly increase the productivity of the industrial engineer in building cloud manufacturing service, and in turn can facilitate promoting cloud manufacturing. Future work of MSACS include supporting software written in other imminent languages such as Python and R, and adapting the emerging virtualization technology Docker container for automatically constructing containerized cloud manufacturing services. Thank you for your listening.
Okay, any questions for the paper here? Okay. So I have a question. So what's the most complex example you have implemented using this framework?
For example,
Microphone.
Okay. For example, in the first version, we built the AVM service manually about 4 years ago. So the three student construct that system about take 3 months. So it's take long. So for example, in the industry, usually the engineer lack the programming experience. So if you adopt our system, we'll help them a lot to create a cloud service.
Okay. How long does it take?
Pardon?
How long it takes now? How long?
Here.
What's the difference between then and now?
I here. Yeah, this one. For example, here, I explain to you, we compare the novice, which is, it's a novice, which lacks web service programming background before. So they need to learn how to do web service programming. Then we also compare a skilled programmer and professional. He's very familiar with service programming. So the right-hand side is MSACS. You can compare the difference. It's much faster.
Right.
Yeah.
Okay. Thank you very much. Thank you.